So we're talking about how to name alkanes. And we went over the IUPAC rules, and sometimes we just need to do some examples. And this section is about how to apply those rules. So I think these examples that they have here are helpful. If we look at this first one, they've numbered the carbons for us. We can see that the longest chain has 5 carbons. They started the numbering from this end so that this methyl group is beyond on the second carbon. So we're going to call this 2-methyl pentane, not 4-methyl pentane. Because if you draw 2-methyl pentane and 4-methyl pentane, all you have to do is rotate it around and it's exactly the same molecule. I'll be showing you some models later. But molecules, you can look at them from different sides. And so you may draw your structure one way and your friend might draw it another way, and you could both be correct because you might be taking a picture of the front of the molecule and the other person is drawing a picture of the back of the molecule. This is pentane because the longest chain is 5 carbons. If you have any questions, please interrupt me. Looking at this one. This one is drawn so it might appear that there's 5 carbons in the longest chain with an ethyl group hanging down. But we have to check and find the longest continuous chain. And if we start counting here and wrap around, you can't backtrack. You can't hit a carbon twice. You just go from one to the next and find the longest path. We see there's actually 6 in a row. And then this is considered a substituent attached to this carbon. This has 1 carbon, it's a methyl group. We're going to number from this end, so we're going to end up with 3-methyl hexane because there are 6 carbons in the longest chain. We're not going to call this 4-methyl, we're not going to call it 2-ethyl pentane, because that would be overlooking the longest chain actually being down here. We're not going to call it 4-methyl hexane because that would be numbering it from the wrong end. So when we draw the structures, there can be differences. When we write the IUPAC name, it should always be exactly the same. Some people find that restrictive. I find it comforting. I like things where there's one right answer. 2 plus 2 is 4. Let's look at this one. This one is a little more, branched and complicated. We're going to look and find our longest chain is 4, so this is butane. And then we've got a methyl group here and a methyl group here. They're both attached to the number 2 carbon because we're going to choose to number it this way so that they have the lowest number. And so we give both of them, we indicate the number for both, even though it's the same number. It's 2, 2 dash dimethyl butane because there's 2 methyl groups on there. We're not going to call it 2 methyl butane. That's leaving out the prefix di. And we're not going to call it 2 dimethyl butane. I like this table because it shows some of the common errors that students make when they're starting. And then there's this guy down here, 4 carbons, so it's butane. And we've got chlorine and we've got bromine. Now, if we numbered from the other end, the bromine would be on 2 and the chlorine would be on 4. Numbering this way, we have 1 and 3. Those numbers are lower, so that's better. Then when we choose who gets to go first in the name, we're not doing it by the number. We're not going to put 1-chloro first. We're doing it by the alphabet. B comes before C in the alphabet, so bromo comes before chloro in the name. So it'll be 3 bromo, 1 chlorobutane. Any questions? Most of the figures and tables that I'm showing you in the slides are in your textbook, and so you don't feel like you need to, scribble them down or anything. They're also up on the OneDrive, and you can print them out if you would like. So from We've been learning how to name. I kind of gave you a preview of writing structures, but we need to be able to take those names and write structures from them. And these are the basic steps. First, you write the longest carbon chain and number it. You get to choose which end you number. I would recommend writing them in a straight line, your carbon chain, just making it a straight line. Why make things more complicated? Start on the left with number 1. You don't have to, but we start everything else on the left. Why not number your carbon chain on the left? And then you're going to add the substituents that are indicated in the name to the correct carbon atoms. It's like this little road map. 2-bromo tells you there's a bromine atom on the second carbon. And so you're going to fill those guys in. And then after you get all those guys put in, then you fill in with hydrogen atoms so that all the carbons have 4 bonds. So let's do an example. Let's write the condensed structural formula for 4,5-diethyl 3,4,5-trimethyl-octane. Wow, that's a mouthful, huh? By the way, when you're done with this class, you should be able to pronounce a lot of the ingredients on processed foods. And you can amaze your friends. They don't even need to know that you might not know exactly what that is. But it's all prefixes and suffixes, and you just look at the little chunks and you string them all together and they're all impressed. Okay, so what we're going to do is we're going to first look at the end of the name, octane. How many carbons? 8. So I'll make a string of 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. I told you there's a lot of counting. And I'm going to number that. 1, 2. After you have a little practice at this, you might not actually have to put the numbers on there, but for now, just go ahead and do the numbers. Then we're going to do substituents. So the substituents are these guys at the beginning. 4,5-diethyl. On the 4 carbon and on the 5 carbon, each of them has an ethyl group. How many carbons in an ethyl group? 2, because mom eats pickled bananas. It's the second one. So on this 4th carbon, I'm going to put an ethyl group. And on the 5th carbon, I'm going to put an ethyl group. I could put them on top if I wanted to. It doesn't matter. I could put one on top, one on bottom. It doesn't matter. So those are the ethyls. And then we have the methyls. So trimethyl, there are 3 methyl groups, 3, 4, and 5. So there's one on the 3rd carbon. There's one on the 4th carbon. Now we already have something on the bottom, so we're going to have to put this one on the top. And one on the 5th carbon. So now I've got my skeleton taken care of. Now I'm going to put in hydrogens so that everybody's happy. All the carbons have the right number of hydrogens. So this guy on the end has 1 bond. He needs 4, so he's going to have 3 hydrogens. The next one has a bond to this carbon and a bond to that carbon, so he needs 2 hydrogens. How many bonds does this carbon have?
1.
It has 3, so it needs 1 hydrogen. So I can put that right here. I could draw it on top if I want to. What about this guy down here? How many hydrogens does he need? He needs 3. All the guys at the end are going to need 3. So this guy, 3 hydrogens. This guy needs 3 hydrogens. This guy over here at the other end. Because all the ones at the end only have 1 bond, and so the other bonds need to be made up with hydrogens. They have 1 bond to a carbon atom. The other bonds are to hydrogen. So carbon 4 and carbon 5 already have 4 bonds to other carbon atoms, so they're not going to get any hydrogen atoms. This carbon here has 2 bonds, so it needs 2 hydrogens. Same for this guy over here, and this guy, and this guy.
I'm confused. Why are we putting hydrogens in there? Like hydrogen on the carbons?
It is a hydrocarbon. The alkanes are hydrocarbons. They have carbon and hydrogen. The carbon is like the backbone, the structure of the molecule, but all the carbon atoms are going to have 4 bonds. And in an alkane, they're all single bonds. So whichever bonds it doesn't have to other carbon atoms, it needs to have to a hydrogen, because the octet rule is going to be satisfied by all of these atoms. We don't mention the hydrogens in the name because we can assume that they are there. So the octane tells us there are 8 carbons in the chain. Methyl and ethyl tell us the number of carbons in each of those substituents, and then the hydrogens are assumed, and so we can just draw them in. It's a good question. Any other questions? Yes?
How would you draw the molecular formula for them?
How would I draw the molecular formula?
Right.
Well, you would have to do some counting. We'd have to count up all the carbons. We know there's 8 in here, but then there's 9, 10, 11, 12, 13, 14, 15. So that would be C15. And to get the number of hydrogens, you can either add up all the hydrogens in there, or do you remember what the general formula for an alkane is? 2N plus 2. So N would be 15. 2N is 30 plus 2, so there'd be 32 carbons. And it's that sort of a situation, trying to make a molecular formula out of this big old mess, that knowing the general formula comes in really handy, because you don't actually have to count them all. This formula is not that useful because there are many, many different isomers of this compound. If I take this carbon and move it over here, I'm going to have a different compound, different isomers. And so it's just not so useful. That's why we used the condensed structures and stuff more often. Any other questions?
What's that formula again?
This is the molecular formula. This is more what we're familiar with from general chemistry. Just
No,
as,
I meant like how'd you get it?
oh, how did I get it?
Yeah.
Okay, the general formula for an alkane is CnH2n plus 2. And the reason that is because all of the carbons that are in the middle of a straight chain are going to have 2 hydrogens, and all the carbons at the end are going to have 3. It's easier to see how that comes about from something a little simpler. So what happens with the straight chain is this part here, there are twice as many hydrogens as carbons. And then there's going to be 2 ends, and there'll be a hydrogen on each end, and that's where the plus 2 comes from. When you mess it up and make it branched, the numbers still work out exactly the same. But that can be a thought problem that you may or may not want to think about. Any other questions? This takes practice. It takes practice, and then seeing, did I get the right answer? And if you didn't, go back and try it again and figure out how the right answer is the right answer. And if you're not making any headway, get some help, because it's not going to go away. Okay, learning how to do something like this is very, very foundational, because we're going to be doing nomenclature all the way through, and we're going to be adding new things. And so if you don't get the basic foundation, it's just going to get harder.